Hi O'Connell, happy Thursday. So this is lesson 2 of the week. We only have 2 because we're off Monday. So we'll fly through lesson 2, correcting the homework, and then keep going on with patterns. And try and keep this to under half an hour because it doesn't seem to put up the sound onto YouTube and the videos when you go over half an hour. So correct the homework, a few more ideas. Quite difficult, quite tricky. So don't be afraid to ask questions, and as per the poll, we will do a live class or 2 live classes next week because that's what people seem to want. Tomorrow or today even, this afternoon, last class, we have a live science. So tomorrow and then on Monday or Tuesday we'll have a live maths as well. So we'll see what you think. Do you prefer one or the other as when we actually do them? Okay, right. So here's the homework from the last day. I'm going to go through this quite quickly, but you can go back and look at it again if you're not sure. So we're going to have a quick look at some of these. I'm not going to do them all, just a quick correction of some of them because they're pretty much the same. So we, for question 1, we'll do question 1C. So what they're saying, they repeats every 3. So after every 3 shapes, it repeats. So you can see that down the middle there, after the third, after that blue square, it repeats. So what they're asking you, what's the next shape going to be? Well, if we have circle, sun, square, circle, circle, sun, square, circle, sun, square, then our next answer is obviously going to go back to the start again, and it's going to be a red circle. So just write or C. And if I go over to the answer then and check the answer to 1C, I would imagine, yes, it is a circle. The next one is something very similar. So we have, we'll just do the bigger one, part B. So we have all different cubes, blue, red, green, blue, red. So that's our sequence or our pattern. We have to go to the next 3 blocks. Well, if the pattern ends there, then we just start at this at the start again. So if this is going to be number 1, 2, 3, 4, 5, then it's going to go back to the start again. 6, 7, 8. So these are going to be, your answer is going to be these 3 here. So it asks for the color. So it's going to be, our answer is going to be blue, red, green. And if I check the answer to 2B over the far side, it says blue, red, green. Okay. Question 3 then is up here. Question 3, 4 block repeating patterns. So all you have to do is put in the color of the block in 1, 2, 3. So it's, for example, it's going to go blue, 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 red, blue, 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 red. So the 6th block is just going to be that answer there. It's going to be a blue one. The 8th block is going to be, well, the 8th block is this one here. And what colour is the 10th block? Well, the 10th block we don't have on this. So you're wondering, well, if it goes 1, 2, 3, 4, then it starts again, 1, 2, 3, 4. We're just going another 2. So our answer is going to be up here, which is, it's going to be blue, because it's a repeating pattern. Okay, and that answer will be over on the right hand side for you as well. Keep going on nice and quick. A 5-tile repeating pattern is here. So they give us tile 1, tile 2, tile 3, tile 4, and tile 5. So we could write the shape. You could draw the shapes in there. For example, it's going to be a triangle. That's going to be a square. That's going to be a circle. That's going to be a triangle. That's going to be a circle. So there's our pattern. It's obviously horrendously drawn, but still. But it stops at the end here. So it then starts to repeat again. So the 6th tile is going to be starting at the start. The 10th tile is going to be, so this is going to be 6, 7, 8, 9, 10. So 10 is going to be here. So 10 is going to be a circle. That's going to be a circle. That's going to be a triangle. The 21st tile. Okay, so we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's going to be 11. That's going to be 11 to 15. That's going to be 16 to 20. And our 21st is going to be at the start again. So our 21st is going to be at the start again. You're thinking, oh, how many sequences have I got to get to 21? Well, I have 5 in the 5 shapes. I've had to go 4 sequences plus 1. That gives us the 21. So it'll tell you to go back to the first one. Tell us it's a triangle. If you're stuck on that now, ask me. A 6 marble repeating pattern. How many times does a red marble appear? Okay, so we have, here's our 6 marbles. 1 is there and 6 is there. This is also going to go back to the start again to the blue. It's going to be 7, and that's going to be 12. Then it's going to go back again. This is going to be 13. This is going to be 18. And then this is going to be 19, 20, and 21. So 21, this is where the pattern stops. So you say, well, how many reds are we going to have? Well, in the first time you go from left to right, you're going to have 2 reds. And that brings us up as far as 6. The second time you're going to have 2 reds, which brings us up as far as 12. The third time you're going to have 2 reds, which brings us up as far as 18. And the fourth time you're only going to do 19 and 20, so it's going to stop here. So we are looking at only having 1, because this red won't be in the last pattern. So 2 plus 2 plus 2 plus 1 is going to be equal to 7. And the last one, repeating pattern made up of 6 tiles. So they want you to write in here the shape. So number 1 is going to be a triangle, and the colour of that is going to be red. I'm not going to write all them in for you. So we have 1, 2, 3, 4, 5, and 6, or if you want to number them up on the actual shapes. And then we're looking for the 10th tile. So I go back to the start. Number 7, number 8, number 9, number 10. So what shape is the 10th tile? It's going to be a square, and so on. And I did that for the 15th as well. I could just count them until it gets to something like this, until it gets to 37. And when it gets to something like 37, it can get a bit confusing. So what we're going to do for tile number 37 is we're going to say, well, how many patterns are we going to need to go through? How many times are we going to have to go from left to right to get to 37? Let's try them. I'm going to have 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30, plus 6 is 36, plus 1. And whatever the last, so I think 6 and 6 is 12, 18, 24, 30, 36, and then this one here is our key answer. That tells us the answer is going to be the this one here. So it's going to be a red triangle. Or if you know how many times does 6 go into 27? It's going to go in. It's going to go in 4 times. So if we count our 6s, 6, 2, 3, 4, 5, 6. So it's going to be 6 multiplied by 6 plus 1, and that's going to give us 37. Whatever way you do it, it just saves you all this calculating, going 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, and so on, and getting up as far as 37. So that's the homework. Okay, now what I want you to do is pause the video and go over here and check your own homework, so I can see the corrections in your homework section here in OneNote, so I can tell Miss McDonald that you're engaging with the homework and so on. Okay, so there's all your corrections there, and you can check your answers. So I'm going to move on. This is when it gets a bit tricky. So we're going to go into different types of sequences. So this, for example, over here is a sequence, and it's just numbers in a line, and we have, if we take 6 to start with, 6 is term 1, so the first term. 10 is term 2, 14 is term 3, and 18 is term 4. If we had another number after that, it'd be term 5. If we had another number after that, it'd be term 6. And instead of writing term, we usually see them written as T1 and T2. So a pattern that is ordered is called a sequence. So if the pattern is in order, it's called a sequence. See the way this pattern over here has numbers in it? If it has numbers in it, it's called a number sequence. This one up here with the balls, so this one up here, has no numbers. So this is a sequence. This is a sequence here. But this one down here is also a sequence, but it has numbers, so it's a number sequence. Okay? So if we have a look at the different types of sequences, In a linear sequence, the difference or change between one term and the next is always the same number. This means that change in a linear sequence is constant. Now, what on earth does that mean? Right, well, let's go have a look over here for a second. 6, 10, 14, and 18 are the numbers they give us. So we have 6, 10, 14, and 18. So here's our number sequence. And I'm going to put little v things underneath there. And I'm wondering, what's the difference between all those numbers? What's the difference between 6 and 10? What do I have to do from 6 to get to 10? And the answer is, I'd have to add 4. To get from 10 to 14, I'd have to add 4. To get from 14 to 18, I'd have to add 4. The answer is, if all of these are the same, that means it is a linear sequence. If those answers are all not, if all of these don't work, if all of them do not work out as 4, it's not a linear sequence. So I'm going to make one up off the top of my head. Let me see. So if I go and I say, right, 4, 6, 7, and 9, and I go for my differences again, and I say, well, that's plus 2, this is plus 1, and this is plus 2. So I'm looking at my differences, my common differences. No, doesn't work, does it? Look, this fella here. No, so this is not linear. Not a linear. Okay, so that's how you tell the difference. Okay, so let's go back to the way they do it. So basically, they've done the same as we've done. If they've added 4 and added 4, and what they're looking at there is the first difference. So this is these are the first differences. So the difference between here and here, here and here, and here and here. That distance, the difference in this case is constant, and it's called a common difference. Common means the same. So same, 4 is the same as 4 is the same as 4. So the difference between this number and this number, and this number and this number is the same, or it's common. Okay. Linear, by the way, means straight. So you'll see there, they put it over here into a graph, and you have a nice straight line. So if you have 6, 10, 14, and 18, 6, 10, 14, and 18, in a line it gives you a nice straight line. But we'll be doing the graphing. Don't worry about the graphing. We'll deal with that in second year. Okay. So what the other way they can ask this is they're telling us here that these are linear sequences. So they're telling us that the differences between all these numbers and all these numbers are the same. But what they want us to do is they want us to find the next sequence. So they wrote them out. If you have a look down here at the solutions, they've said, right, here's term 1, here's term 2, here's term 3, and here's term 4. And they're saying, well, okay, well, the difference between 11 and 18 is 7. The difference between 18 and 25 is 7. The difference between 25 and 32 is 7. So you're saying, well, okay, well, there's the common difference. It is a linear function. So if I add 7 on to 32, I'm going to get 39. If I add 7 on to 39, I'm going to get 46. If I add 7 on to 46, I'm going to get 53. So they can ask us to find the next numbers in a sequence, or they can ask us to find whether it's linear or non-linear. And this one here is exactly the same. Okay. Right. The other one, the last way they can work about when they can ask you linear sequences is they can ask you to put it into your own words. So if I go over here and I say, right, 7, 10, 13, and 16. So I'm going to draw it out again. 7, 10, 13, and 16. I'm going to put my V's in between the numbers and I say, right, yeah, difference there is plus 3, difference there is plus 3, and difference there is plus 3. So all of those are the same. So it is a linear sequence. They said to us there, put it into words. Okay, so how would I word that? Well, I'm going to word it by saying it is a linear sequence as the common difference between all terms is 3. I hope that makes sense. That's why it's a linear sequence. We're going to see the difference now in a second when you come up with ones that don't work like that. Now, In non-linear sequences, the first difference between each pair consecutive terms, okay, is not right. So it's not constant. So we're looking at this first difference again. So I'm going to take the numbers that they give us here, 18, 20, 20, and 18. So if I draw them out here, 18, 20, 20, and 18, I do it exactly the same. I put my little v things in. And I say, right, the difference in here and here, 18 and 20 is 2. The difference in 20 and 20 is 0. And the difference in 20 and 18 is minus 2. Oh, okay. All different. So I'm going to say, right, well, if they're all different, we haven't got a common difference. Therefore, it is non-linear. That's the difference. It's going to be non-linear. Okay, so if the first difference, so I'm going to put these are first difference. But what else could it be? If it's not linear, what else could it be? And the answer to that is it could be a quadratic. So instead of having this nice straight shape like this one over here, it could be a different thing altogether. It could be this one here. So we're going to have a quick look and see what that means. So I'm going to take a different one. Let me see. 4. I'm going to take this one here. 4, 4, 8, and 16. So I'm going to go out here and have a look. 4, 4, 8, and 16. I'm going to put my V's in. Difference in 4 and 4 is nothing. Difference in 4 and 8 is plus 4. Difference in 8 and 16 is plus 8. Okay, so I can tell straight away this is not linear because the common difference is not the same. The first difference is not the same. Then I say, okay, let's go down again. Let's go to the second difference. Let's have a look at the numbers that I'm after coming out with there. Sorry, from the microphone. Do more V's and say, right, what's the difference between 0 and 4? It's plus 4. What's the difference between 4 and 8? Is plus 4. Ah, okay, we have numbers that are the same. In the second difference, the numbers are the same. And what that means is that this is a quadratic. So if it's not linear, it could very well be quadratic. Okay? And the very last one is this one here. So we have 3 to consider. 3 to consider. We can have 3 types. 1 is linear. 2, non-linear. 4, I mean, not 3. 3, nope, hold on. Non-linear. Outside non-linear, you have 2. We have quadratic. And the last one we haven't done yet is exponential. Right? So we come back to our example here that we just did. Here's our 4 terms. Term 1, term 2, term 3, and term 4. We had 4, 4, 8, and 16. So here's our numbers. 4, 4, 8, and 16. We got the common difference, the first difference. So the first difference was 0, 4, and 8. And that tells us straight away that this is non-linear, the first difference. So these 1, 2, and 3 tell us that it's non-linear. But then we have to say, well, what else could it be? And when we go down further, we got plus 4 and plus 4. Because the second difference is the same, it is quadratic. But the last one I want to show you today, if we have 4, 8, 16, and 32. So one more example. 4, 8, 16, and 32. Let's get our first difference. Let's see, is it linear? Plus 2, plus 8, plus 16. No. Okay, so we know from there that this is not linear straight away. Let's see, is it quadratic? Let's get the second difference. 2 to 8 gives us plus 6. 8 to 16 gives us plus 8. Oh, okay. It's also not quadratic. So this shows us not linear. This shows us not quadratic. If the second difference isn't the same, which we have here as 6 and an 8, only other thing it can be is the final type, exponential. You'll hear about COVID. Exponential growth means it's doubling all the time. So the COVID numbers are doubling all the time. So I showed you a bit before, if we're to think of linear. So linear looks like a straight line. Not quadratic looks like a curve, like that, up or down. And exponential looks like that. So you'll know if they ask you a graph in the future, but we'll be doing those again in second year. Okay, and these are just more examples of looking at figuring out which one is which. So if I'm to do one more for you, let's say, let's pick part. If you look at part C here, 2, 5, 36, and 65. So let's say 15. No, this one here. Oh no, we'll do this one. 2, 15, 36, and 65. So let me see. So our cases are 2, 15, 36, and 65. So let me get the first difference. It's going to be 13. It's going to be 15 and 6 is 21. And 66 is going to be 29. Okay, I know from this it's not linear. Let's go again. The difference between 13 and 21 is going to be plus 8. The difference between 21 and 29 is going to be plus 8. Okay, I thought they were going to be different there. So because these were not the same, it's not linear. But because these are the same, we can say it's quadratic. Quadratic. Okay, now again, I'm trying to keep this video under half an hour, so it uploads for you to do. This is due for Monday, right? So it's only on exercise 11.2, so chapter 11, and the 7 questions, well doable within the hour, so within the next the second half of today's lesson. They're all based on the notes above, so you can have a look at the notes that I drew. You might need to watch this video more than once, to be honest with you, to get your head around what it means to figure out whether it's linear, non-linear, quadratic, or exponential. But you have questions 1, 3, 5, 6, 8, 11, and 12 to do for homework, and I want those uploaded by, oh, that was a mistake, uploaded by Monday morning, so I can check them and tell Miss McDonald that you're all keeping up to date with your stuff. So I'll see you all for science last class today, and then we will do some live maths as requested in the poll next Monday, and probably next Tuesday, so we'll see how Monday goes. Okay, right, see you guys.